Now we're going to look at booklet B. So question 16. Name the organ marked Z. Well, it's quite obvious. The organ marked Z is the ovary. Part B is supposed to explain how reproduction will be affected when the fallopian tubes are cut and tied. So this is the fallopian tube. Alright, so if I cut and tie it, what's going to happen? So basically the egg, when it tries to come out, it will be blocked. And so without egg, how would reproduction be affected? Basically, you have no egg to fertilize. So this is how you can structure your answer. So the egg will not be able to fuse with the sperm. Alright, so this is a simple answer that you all can give. Now let's look at question 17. Supposed to study the family tree below. So basically they ask part A, how many generations are shown in the family tree? Okay, so I want the word generations. So basically, like I explained to some of you, generations is, let's say, Jack, his siblings, his cousins, these are all one generation. His father, his uncles, his father's siblings are all one generation. His father's father, that means his grandparents, is another generation. And then above them is another generation. So a family tree shows generations. So each level is one generation. So how many levels are there? So there are 4. So how many generations are shown? Basically 4 generations are shown. Which parent, mother or father, did Jack inherit his detached earlobes from? Okay, so let's see. Male detached earlobes are shaded. Female is shaded with a circle. So let's look. Jack, he's a male with detached earlobes. Who did he inherit from? Well, this is a male. This is his father. So which parent will be his father? So question 18. So diagram below shows the water cycle. So they ask you what are the states. Okay, so keyword here, I want the states of water. So I don't want you to tell me rain, cloud, I want the state. State means solid. There are only 3 states. Solid, liquid, and gas. Alright, so let's look at B. What state does B represent? So B is water droplets or clouds to B, and then to water in seas and rivers. D is going through evaporation. Then I get D. So from D it condenses into water droplets. So it's very obvious. B is liquid. Okay, because water droplets is liquid already. And D, after evaporation, it will be gas. Okay, not water vapor, because I want the state. A state is solid, liquid, or gas. So please remember that. Now, question 19. 2 identical cups filled with 300 ml of ice water. Y is filled with hot water. Leave left unattended. Notice some condensation. So you're supposed to draw what he will observe in 20 minutes. Okay, so let's draw. Well, if it's cold out here, so this means if this part here is colder, the cup will be much colder than the surrounding. So my water droplets will basically form here. Okay, so my water droplets will form on the outside. Now, it will not form up here because up here is not cold. Okay, so it will only form where there is the cold water touches, because then this part here of the cup is going to be much colder. Alright, so this is for this cold cup. Now for hot water, there won't be any condensation on the outside. Obviously not. Alright, because it's going to be very warm. But what's going to happen is that water vapor will start to evaporate. Okay, sorry. The water will evaporate because it's hot. This hot water vapor will be floating around the cup, but once they come in contact with this part here, the cooler surface of this part here of the lid and of the side of the cup, they will start to lose heat and change to water droplets, and they will condense. So basically you will see water droplets all over, but on the inside. Okay, so normally when you have hot drinks, you actually see water droplets all on the inside of the cup. Sorry, you should draw it it should be touching the surface. I'm experiencing a bit of lag here. Okay, so draw it on the inner surface. Let's erase this. Let's do this nicely. Okay, so there should be water droplets on all this side here, from here to here to here, because everywhere the water will start to condense. Okay? Now question 20. So Ben set up the experiment as shown below. Okay, so what's happening is there's a Bunsen burner, there's boiling water, then there's this glass tube. Alright, there's this X with cold, wet towel. Basically, it tells you to cool the glass tubes, and then you see water droplets down. Okay, so what is the process that's happening in the glass tube at X? So basically, we need to understand here, when it boils, we need to remember that boiling causes liquid to turn to gas. So boiling causes liquid to change to gas. Eesh. Okay, so all this gas will start to float and go through the tube. Now because this is a cold wet towel, so what's going to happen here is the gas will change back to liquid due to what is the process called? Condensation. So that's your answer here. Okay, so the process is condensation, not evaporation. So you're supposed to explain what happens next to the water vapor from the boiling tube water when it touches the inner surface of the cool glass tube. So basically what they are trying to ask is for you to explain the process of condensation. So always remember there are a few things you need to remember. So condensation, so basically the answer for B, a few things you need to take note. So water vapor touches the cooler surface. So that's the first keyword, cooler surface of the glass tube. Next, you have to say that it loses heat and then changes into water droplets. So there are four things altogether. It must start with water vapor. Then we talk about touching the cooler surface, losing heat and change to water droplets. Repeat after me. Water vapor touches the cooler surface, loses heat and changes into water droplets. Remember this. This is the most common question. They will always ask you about condensation, and this will be your answer. Alright? So 21, this one shows a change in temperature of 100 ml over a period of time. Okay, so which of the lines on the graph represent the process of forming water vapor in the water cycle? So I want forming water vapor. So when I form water vapor, basically that means my liquid change to gas. And so if you recall, liquid to gas, there are two processes, boiling as well as evaporation. So basically, if you look carefully at every point in the graph, because remember, evaporation takes place at any temperature. At every point in the graph, evaporation is occurring. Okay? It's just at how fast. So that means that which lines represent the process of forming water vapor? Well, it's everything. So it is basically from A to E. So A to E represents evaporation. Now, but it's not wrong if you tell me B to C, because B to C represents boiling. Okay, so you can either tell me A to E, or you can tell me B to C. So either one of these answers are correct. So what will happen to the temperature of water if more ice is added at E? Okay, so if I have more ice added at point E, so what's going to happen to the temperature? Now point E is already at 0 degrees. If I add more ice, what's going to happen? Is it going to drop anymore? No, right? Because it's already at 0 degrees, and if you put more ice, it doesn't drop the temperature down. So what's going to happen is the temperature will remain the same. Okay, so temperature will remain the same. Now, question 22. Sherman wants to investigate. So what's he investigating? If the size of the opening affects the rate of evaporation. So this is my variable that is changing. Size of the opening, because that's what I'm investigating. So he used 3 containers, 3 different types of liquid. So what he used, 3 containers, 3 different types of liquid of the same volume. Okay, so I've got same volume. And put them side by side in an open field. So they are the same location. Hot and windy was not conducted. So name one other variable he should have kept the same experiment to be fair. So if you look at testing, he's testing the size of the opening. So what he's testing. So what else is wrong? So you look at all other variables. Same volume, okay. Open field, same location. So what's different? What is the one that is wrong? Yeah, here he used 3 different types of liquid. So that's not fair. Yeah, you should be using the same type of liquid. So the type of liquid is the variable that he should have kept the same. Alright, now why is it important to place all containers at the same location to ensure a fair test? So why do we need to put it at the same location? Well, so that I can keep the variables the same, because same location means my heat and my wind will most likely be the same. Okay, so that's how you're going to phrase your answer. It will look something like this. So that any changes is due to the opening size of the container and not due to any other variables. So basically you're explaining about fair test. Now question 23. So diagram below shows how shows a river running downstream. Minister wants to process water from the river for the purpose of drinking. So he wants to get the water along the river. So where should he put it? Now if you look at the legend here, this is the direction of the flow. I've got a farm with fertilizer, I've got houses here, I've got schools here, I've got a factory here. So where should I get water from? Well, basically, the best place is actually at the top here. Okay, anywhere along this part here will be the best, because once the water starts going down, the farm with fertilizer, the fertilizer may spill in, houses will throw litter in, schools may dump litter in, factories may dump pollution in, so the whole river may get polluted. So the best is when it just starts. So explain your answer is look something like this. So the easiest way is to explain that the water upstream is not polluted. Now question 24 is a very common, we have actually looked at this kind of question before. So this flask based on hot water, when I first go in, the drop of ink seems to drop a little before rising up. So why is that so? So I've actually explained this before. When you first put the flask in, the flask will expand. And when the flask expands, there is space inside. So then this drop of ink will actually drop in, because there's a sudden there's increase of space, so the ink can drop in. Then after the air inside this flask starts to heat up, the air inside will expand, and then this ink will get pushed up because the air will start pushing. Alright, so this is how you explain. So a few things. There are 4 points here. Flask gains heat, expands first. Okay, so remember this, whenever you want to explain or talk about expansion, always talk about gain heat. Okay, this comes together like twins. Now then the air in the flask gains heat and it expands. Okay, so there are 4 things altogether. The flask must gain heat and it will expand. That's why the ink drops. Then the air in the flask will gain heat and then it expands. Okay. Question 25. Study this experimental setup below. What will happen to the temperature of water if the L-shaped metal bar is heated strongly for 10 minutes? So basically what's going to happen is the heat will flow, it will go in and it will flow into the water. So what's going to happen to the water? The temperature of the water will rise. So explain your answer. So reasons because heat will travel through the L bar into the water. Alright, so basically this question is about heat conductor, heat being able to flow from one place to another and able to flow in through the metal bar, because the metal bar is a good conductor of heat. Alright, thank you, see you.